Hiya, welcome to Number Club. This is GCSE Algebra, functions and inverses. Let's get cracking. So the first things that you need to know about function is actually what they are. And you would have learnt about a function, the very first functions you probably would have learnt about were probably when you were in primary school. And you were taking numbers and you were putting them into function machines. Now, these are called function machines and they are just a different way of writing a function. And in this case, if 5 goes in, we can multiply by 2 to get 10 and add 1, and we'll get 11. Okay, and if negative 2 goes in, negative 2 times positive 2 is negative 4. Negative 4 plus 1 is negative 3. And you could also, you probably learn how to work backwards as well. You could take 7, take off 1, and divide by 2, and you could get 3. Now, that is a very basic type of function. That is essentially what's covered for the most part in GCSE, simple functions like those. Now, if we are dealing with a function, we'll call it f for function, when x goes into it, the output of that function is f of x. Okay? This is the function applied to x. So when something goes in, we apply the function, you get out f of x. Also, you can work backwards. If you work backwards, then this becomes not the function as you go through it that way, but working backwards calls the inverse function. Okay, so when f of x goes through the inverse function, you get back to x. Functions take you one way, from a question to an answer. Inverse functions take you from your answer back to your question. Those are very basic types of function machines. You can also have different notation for functions. So f of x might be equal to 2x plus 1. In other words, this function takes values of x and substitutes them into here. So we'll take a value for x, we'll substitute it into here, and you'll get an output value. This is the function. It doubles things and adds 1. The function applied to x doubles x and then adds 1. So x goes in, we double, and then add 1, and we get out f of x. Okay? When x goes in, you double it, 2x plus 1, 2x plus 1 gives you f of x. That's one type of notation. Another type of notation is that there is a function f containing variables x such that we've got x being multiplied by 2 and adding 1. Okay? That is another way of writing the exact same type of function. You could literally just swap this chunk with this chunk if you wanted to. In fact, this is a lot easier to manipulate. It's a lot easier to deal with. People tend to find that a little bit more simple to deal with, but you have to know what this is as well. Okay? So those are the two types of function notation that you'll see at GCSE. Those are the ones that you need to know about. You should know that when you're going through a function, you'll get from x to f of x, and when you're going for the inverse, you go from f of x back to x. Okay, so we go one way to get f of x, and we go back to undo. All right, moving on. Given that f of x equals 3x plus 5, find f of 5. Now what happens here is when we're dealing with f of 5, we're replacing x with a 5. Place it into the function. I tend to place it in with the brackets around it. So we have the function applied to x would be 3x plus 5, so the function applied to 5 would be 3 5s plus 5. Well, that would be 15 plus 5, which is equal to 20. Nice and easy. F applied to negative 3, you would have f of negative 3 is going to equal 3 negative 3's plus 5, which is going to be negative 9 plus 5, which is negative 4. Easy peasy. This question is a little bit different. It says find x such that f of x equals 26. So this chunk here is going to swap with this chunk up here. So we're going to know that 26 is equal to 3x plus 5. 26 is equal to 3x plus 5. So we'll take 5 off each side. And we'll end up with 21 equals 3x. And we'll divide through by 3. And we'll find that 7 is equal to x. Now have a think about that. Would f of 7 equal 26? Is that true? Well, 3 7s are 21 plus 5 is 26. Yeah, that's true. That's absolutely fine. Okay, so what we're doing when we're doing these solve questions is we are applying the inverse function. The inverse function calls on us to take away 5 and then divide by 3. The inverse function, which is this one, calls on us to have x, take away 5, and then divide by 3. Without really knowing, we've managed to produce an inverse function. It's not incredibly clear, but that's what we've managed to do. The inverse function takes your output, takes 5 off it, and divides by 3 to give you back your input. Okay, let's take a look at one of these ones with this weird notation here. There is a function containing variables x such that the function is 3 subtract x squared. So we've got f of 3. So the function applied to 3 would be 3 minus 3 squared. That's 3 minus 9, and 3 subtract 9 is negative 6. So f of 3 is equal to negative 6. Okay, nice and easy. We'll try the same thing with negative 3. You've just got to be a little bit more careful with that. So the function applied to negative 3 will be 3 minus negative 3 squared. And now you can see why it is that I like to put in with the brackets. Put the brackets in with it, because when you square negative 3, we're doing negative 3 multiplied by negative 3, which is positive 9. Remember that when you square a negative, you will end up with a positive result. So we'll have 3 subtract this chunk here worked out to be 9, which is negative 6. It's okay for these to be the same answer. That's fine. It will happen with this type of graph because this is a quadratic graph. Find x such that f of x is equal to negative 22. Okay, so we'll get 3 subtract x squared is going to equal negative 22. Now what we're going to do is we're going to take away 3 from each side. So we'll get negative x squared is going to equal negative 25. We're going to multiply through by negative 1 to change the signs. Basically, you would pretty much automatically just cancel off the negatives. Okay, and then we're going to square root. And so we'll find out that x is equal to the square root of 25, which is 5. Okay, x is equal to 5. Also, another square root of 25 is negative 5. For very much the same sort of reason from up here, negative 5 times negative 5 make positive 25. There are 2 roots to each number, and so you should watch out for that, but most of the time you'll just give the positive one and it'll be absolutely fine. Let's take a look here though, because we actually managed to form the inverse, managed to form it. You'll do x take away 3 multiplied by negative 1 and then the root of all of those things. It looks a bit horrible, but and it'll only work under certain circumstances, but what you actually end up with is going to be the square root of 3 minus x, and it only works under certain circumstances, that one. Okay, moving on. Given that h of x equals ax plus b, and that, this should say h, sorry, not g, I should say h as well, and that h of 2 equals 4 and h of 5 equals 7, find the values of a and b. So let's get cracking with it. First thing is that we know that h of x is equal to ax plus b. And from our first bit of information, h of 2 is equal to 4. So h of 2 would be 2a plus b, which is equal to 4. You see that I've swapped the x for the 2, and I tend to like putting it in front of the a. So I now know that 2a plus b equals 4. Let's do a similar thing over here. We've got h of 5. Well, h of 5 is going to equal 5a plus b, which is equal to 7. And so now we know that 5a's plus a b is equal to 7. And we also know that 2a's plus a b is equal to 4. Now this is a pair of simultaneous equations. You should recognise simultaneous equations. You might already have done them. If you haven't though, this was a simple enough one so that I can show you a really quick run through of it. If we look at the difference here between this equation and this equation, there are 3 more a's. Okay? If we did this equation, take away this equation, we'd do 5a take away 2a, which is 3a. b take away b is nothing, there's no difference between those. And 7 take away 4 is 3. So 3a's must be equal to 3. A is equal to 1. And if a is equal to 1, 5 times 1 plus b must have equaled to 7. A is 1. And so therefore b is equal to 2. So a equals 1, b equals 2. There are other questions that are a little bit more difficult than that, where you've got maybe different coefficients to b, this isn't a lesson about solving simultaneous equations. If you want to solve some simultaneous equations, you need to look it up. Okay, moving on. Given that f of x is equal to 3x plus 7, find f to the negative 1 of x. Alright, now this we should know that you're going to get x minus 7 divided by 3. You're going to undo the function. We know that it's going to be this. Okay, or this thing in front. Okay, we know it's going to be that because that's what you get when you inverse this function. But what I want to use this question for is to show you a way to deal with not just this type of question, but the really difficult types of question where this style doesn't really work very well. So what we do is we'll swap f of x for y. So we'll have y equals 3x plus 7. We'll take away 7 from each side and we'll divide through by 3. Essentially what I'm doing there is I'm getting x to be the subject. I'm changing the subject of this equation so that x is the subject. And once I get this, this gives me my form. You can see that I've got a minus 7 and I've got an all over 3. This gives me my form. This here is very, very, very useful. You'll use this all the way through the more difficult questions that are coming up and also through whenever this comes up at A level if you're doing it. So the form will be, well, we know that we wanted the inverse of x, the inverse function applied to x, pardon me, and we know that y needs to swap for x. Okay, if we're going to have an inverse function applied to x, this has to include x. It can't include y, for example. All right, that idea gives you the form. That's what the form is, and then we go from there to your final answer. So let's try a similar one. We've got y is equal to 2 over x plus 5. Y subtract 5 equals 2 over x. Now we should know that we can actually swap this x with this y minus 5. We should know, for instance, that 5 equals 10 over x and x equals 10 over 5. Okay, if 5 equals 10 divided by x, x would have been 2. 2 equals 10 divided by 5. True. These things can swap. You'll also do something very similar to that with SOHCAHTOA trigonometry. Provided you swap absolutely everything, you can swap them. Okay, essentially what I'm doing is multiplying up by x and then dividing by y minus 5. So we get x equals 2 over y minus 5. That's my form. So we've got g to the negative 1 I'm trying to find is going to be the x, and we'll get 2 over, swap the y for the x. Okay, so use this stuff to get your form. There's my form. And once I've got my form, I can use that to give me my final answer. Alright, moving on. Now you'll recognise something that looks like this, hopefully, from changing the subject of the formula where the target variable appears more than once. It's the more difficult type of changing the subject of the formula. I'm going to run through it quite quickly, so you might need to look it up on a different video to get a little bit better of an idea how to do it. So we've got y is equal to x plus 3 over x minus 2. We do not like that there are multiple x's. We also don't like that there's a denominator on there. So we're going to multiply up, we're going to flatten it out. Now I don't like that there's brackets. I like everything to be flat and expanded. Okay, so flatten it out, get it expanded. Now I'm going to get all of my x's on the exact same side as each other. So we'll have yx, this will turn into a negative x, equals positive 3, this will turn into a positive 2y. Get them all on the same side, factor out your x. Okay, x's into yx go x times, how many x's go into x is 1. Okay, and once you've got that, you can move the coefficient bracket to x as a denominator down here. There's my form. As soon as I've got x to be the subject, there's my form. So the inverse would be, if the original was p, then it would be p to the negative 1 of x is going to equal 3 subtract 2x over x subtract 1. Alright, and similarly with this sort of job here, we've got y equals, actually this is a little bit of an easier question. I'm going to expand straight away because why not? 10 minus 15x all over 7. 7y equals 10 minus 15x. 7y minus 10 equals negative 15x. Dividing through by negative 15, we'll end up with 7y minus 10 all over negative 15 is equal to x. When you're dividing by this thing, we can change all of the signs in this fraction here. I don't like to divide by a negative, so what I'm going to have is negative 7y plus 10 all over 15. Essentially what I'm doing is I'm multiplying both the numerator and the denominator by negative 1. Okay, that will equal x. There's my form, so I know that q to the negative 1 of x will equal negative 7x plus 10 all over 15. Okay, that's a very, very quick run through of functions and inverses of functions. Hopefully it helped. Thanks for watching. There are more videos on numberclub.org, but at the moment those are mostly A-level videos. There's not too many on there just yet, but hopefully that helped. Thanks.